is Chapter 11, Section 3, and it's on water pollution. The objectives for this PowerPoint are going to be to compare the point source pollution and non-point source pollution, to classify water pollutants by their 5 different types, to explain why groundwater pollution is difficult to clean, to describe the major sources of ocean pollution and explain the major effects of pollution of ecosystems, and to describe the 6 major laws designed to improve water quality in the United States. So water pollution, the formal definition for it is going to be the introduction into water of waste matter or chemicals that are going to be harmful to organisms living in the water or to anyone that's drinking water that's exposed to it. So waste matter is going to be like your poop, um, animal poop, that kind of stuff. Chemicals could be, it's mainly talking about things like fertilizer, pesticides, or even chemicals that companies will dump illegally into water. And really, almost anything that we do as humans can in some way potentially contribute to water pollution. And that's kind of the key thing to realize here is that it's very difficult to control water pollution because it's just a tricky thing. We're trying to survive as humans. We're trying to make things and have economies, and in the process of doing all that, you can just cause water pollution, whether you're intending to or not. Um, However, the 2 biggest causes are going to be industrialization and rapid human population growth. And the key word is rapid because population growth is one thing, but when it happens rapidly, the cities can't keep up their infrastructure. They can't keep up their roads and their sanitation networks, their wastewater treatment plants quick enough to support that population growth. So in developed countries, like the U.S. and in Europe, the idea of water pollution isn't really nearly as big of an issue as it is in developing worlds, because in developed countries we have better wastewater treatment plants, we have better drinking water treatment plants, but even in developed countries it's still an issue. But especially in developing countries, um, uh, the idea of clean water is always going to be an issue. Um, and so talking about water pollution, there's 2 basic types. You have point and non-point sources. And the names of the 2 of them kind of give away what they are. So a point source pollution is coming from one point, so one single thing. So you can trace it back to this one thing. So, a leaking oil tanker, like that's one single thing, or a factory, discharging its pollution. That's one single point. Um, when it comes to trying to clean up point source pollution, enforcing cleanup can be difficult because you get caught in these legal battles of trying to get whatever oil company caused the oil spill to clean up that pollution. Or if it's a factory, you're trying to figure out, well, which factory is it that's causing this pollution. And then in contrast, that you have non-point source pollution. So that's going to be something where it's pollution, but it's not coming from one specific source. That's going to be things like water that's coming from streets and storm sewers, where, as water is running down the streets, it's picking up all kinds of different stuff, whatever it is that's hanging out in the streets. And it'll flow into the storm sewers and then go into your wastewater treatment plants, so, or you have water that, when you spray your lawn with chemicals, that whenever it rains, it's gonna if you didn't spray if you just spray lawn chemicals onto your lawn and say it rains like 5 hours later or something, those chemicals, those lawn chemicals, those pesticides, those fertilizers, those haven't gotten a chance to really attach themselves to your lawn, and so they just wash completely off your lawn and then can get into bodies of water. And then this is a table. I won't read all of these, but just different examples of point source pollution and non-point source pollution. And then these are the different types of water pollutants. Again, I won't read all of them off, but some of the bigger ones, pathogens, is going to be something you're going to find in your fecal matter. your poop and stuff like that if that gets into water. Then different types of chemicals, things like heavy metal. Heavy metals can even exist naturally in your groundwater. Um, it's just they usually aren't at a high enough level to occur naturally in groundwater. They're just not at a high enough level to where we really worry about it that much. Okay, so whenever you wash your hands in your sink or you go to the bathroom, the toilet, all that water, flows down in pipes, and it ultimately is going to end up going to a wastewater treatment plant. And a wastewater treatment plant is, as kind of the name suggests, it's a plant that treats wastewater. Um, and there's different. I'll jump to this diagram right here and just walk through the treatment process. Um, so at the making of this video, uh, a year ago, the date of making this video, I actually did an internship at a wastewater treatment plant where I kind of got to go through all these different steps and kind of see how the whole thing worked. And um, it's kind of underwhelming and boring, and was one reason that made me want to be a teacher, so that I do something that I feel like is a little more exciting, I guess, other than watching you know, how you clean up poop and drain it back into the stream. But what I would say is the basic process is kind of interesting how it works, because it starts off with all of things from your toilet, your sink, from different factories, your storm sewers. They all end up coming into the plant. And the first part is you're going to filter out the big objects. And then those big objects, and some of these big objects can be like towels, like literally towels. Like think like a hospital. I don't know if like grandpa's sitting on the toilet and his towel gets flushed down the toilet, but literally like entire towels will be filtered out in this process. Somehow they get into the wastewater. So you're just getting out the giant things in the first step. And then you go to the settling tank in step 2 here. So this is just the giant tank where all you're doing is you're just using gravity. You're just, the heavier things, the things that are more dense, they're going to sink to the bottom of this tank and form the first part of your sewer sludge, where you can have a pipe that drains out this sludge. And then you go to step 3, which is called the aeration tank. And the aeration tank is really where a lot of the magic happens when you're treating your wastewater, because you add, as the name suggests, you add air into this tank here, and that air feeds the bacteria. The bacteria use the air and then the nutrients that are still in the waste to literally like eat the waste. It's kind of I don't know if beautiful is the right word, or interesting, but you're literally using bacteria to eat your poop and whatever else is in the wastewater. The bacteria just eat on all this waste and break down a lot of remaining nutrients that are still in that waste, and then it'll all accumulate down here, and you kind of drain it out and form more of the sludge. And then you go to a second settling tank, and it's the same idea as the first settling tank. The only difference is that the water coming out of here is just a little bit more clean because you've had the bacteria removing a bunch of the stuff. Same thing happens in the second settling tank. You remove some of the sludge. And then the final process is you're going to add some chlorine to disinfect the water. And some plants, a lot of the plant I worked at, they had UV light treatment. So they literally like had a bunch of UV lights, and they just shone that into the water, and that helped to disinfect the water more. And then you dump it out into the stream, and this water coming out of here, um, you wouldn't recommend drinking it, but it technically isn't something that it's drinkable, I guess, if you're in a bind or something, but it's not something you really should be drinking because it's going to have a little too much chlorine in it. Anyways, that's the basic wastewater treatment process. So one of the products is that sewage sludge that I've been talking about, where that sludge, it could have some useful purposes to it, because it still has some nutrients in it where you can use it for fertilizer. You can even combine it with other stuff to make like bricks. But what can happen though is, depending on what's in the wastewater when it comes into the plant, there can be a lot of toxic chemicals that are stuck in that sludge, and because there's these toxic chemicals, you can't put that sludge onto the land as fertilizer. And so depending on how high the concentration of those toxic chemicals, you're going to want to dispose of that as hazardous waste, where a lot of times it's going to be incinerated, and then you're going to bury the ash in a landfill. So the idea of sludge is a kind of a big issue, I guess, for a lot of cities, where you just have a lot of it and you don't really know what to do with it, and some of it is too contaminated to just be able to use for something useful. Okay, so artificial eutrophication. This is something we've touched on in the first semester, and it's the idea of nutrients. So water, is H2O, right? But there's other stuff in water. There's other stuff in a lake or a stream, and you have nutrients that fish and plants can feed on, and those nutrients come from organic matter. Organic matter being, dead animal waste or even things like leaves. Just this stuff that gets broken down by your decomposers, your bacteria and your fungi, and they decompose and convert those organic matter into a form that fish and plants and stuff can use for energy. What can happen though is that whenever you have lakes or slow moving streams, you can end up getting an abundance of nutrients, and that abundance of nutrients is called eutrophic. And eutrophication isn't necessarily a bad process or a bad idea. It's a natural thing. But what can happen is if you get too many nutrients into the body of water, the bacteria that are kind of breaking down these nutrients, they use up oxygen in the process. And if they use up too much of that oxygen, then there's not going to be enough oxygen in the water for the fish to feed on. And depending on the levels of oxygen in the water, that can determine what kind of organisms live in the water. For example, you can have plants that take root in some nutrient-rich soil. And as you get more and more plants, they're going to take over that water. It eventually can become a swamp or a marsh if you get too much plant growth and not enough fish growth. Okay, you can accelerate the process of eutrophication whenever you have runoff. So phosphorus, nitrogen, these are a lot of things that are in your fertilizers that you put on your lawn or you use for agriculture. And as I mentioned, some of this stuff can run off in the rain if you add this stuff to fields right before it rains, or there's not enough time for that stuff to really cling on to the fields. And even some of it, even if you apply it to your lawn or into fields um, with enough time before it rains, still some of it's going to run off into the runoff from the fields. So artificial eutrophication is whenever you have this nitrogen, the phosphorus and the nitrogen that increase the nutrients in the body of water. Major causes of the artificial eutrophication are going to be your fertilizers, as I mentioned, and then even the phosphates that can be found in your laundry detergents can add to this. So phosphorus is a plant nutrient, and so what happens is, the phosphorus and the nitrogen are going to run off and get into these bodies of water, and they're going to cause excessive growth of algae. Now algae, they're a plant, they're a producer, and they're not inherently bad, but what happens is, and where the problem comes in, is when these algae die. And when they die, you have your decomposers, your bacteria and your fungi that come in, and they break down these algae, and they use oxygen, the oxygen that's dissolved in the water, in the process. And again, if they use too much of that, then there's not going to be enough oxygen in the water. You have oxygen depleted water, so there's not enough oxygen in the water for fish and other aquatic organisms to use to survive. Because fish, as I mentioned in the first semester, fish and other organisms, they still need oxygen to survive. We tend to think of oxygen, we tend to think of when we're in water, oh, there's no oxygen. Well, there is oxygen dissolved in water. It's just we don't have gills to access, gills like fish do to access that oxygen. Thermal pollution is going to be where you just have water that increases to where it's too hot. Even if you increase the temperature of water by really not too much, that can affect the ecosystem, the aquatic ecosystem, to where certain types of fish or certain types of plants are adapted to living in a certain temperature of water. And the biggest cause of thermal pollution is going to be from power plants disposing of their really warm water into a lake or river, because power plants use water as the main way that they cool down their plants. You essentially, as you're creating electrical energy for use of, for households and businesses to use, that creates a lot of heat, and so you pump water through the power plants to cool them down. But then the question is, well, what do you do with that warm water? And a lot of times they end up discharging it into a lake or a river, and the problem can be is whenever the water is too warm, whenever you dispose it into the lake or the river. And specifically what happens is whenever water is warmer, uh, the water molecules are moving quicker. And when they're moving quicker, there's not as much oxygen that can dissolve or fit in between the spaces of those water molecules. And so you have lower amounts of oxygen in the water. And it can get to where there's a low enough level to where aquatic organisms literally would suffocate, like we would suffocate if we didn't have enough oxygen. All right, groundwater pollution. So pollutants can enter groundwater, especially through areas in an aquifer where you have more of that porous rock. Things like your gravel, your sand, your limestone, rock that has more spaces in between itself where water can flow into it, right? So we talked about recharge zones, where recharge zones are areas where you have more of that porous and permeable rock, like your gravel, sand, limestone, where the water can get through. But if water can get through, that also means that pollutants can also sink through into the groundwater. And those sources can be pesticides, herbicides, pollutants from factories. And a big thing is underground storage tanks. So there'll be toxic, hazardous waste chemicals that we don't know what to do with, so we put them into a tank and we bury it underground and just kind of forget about it. And over time, that tank, it doesn't last forever. It eventually breaks down, and some of those pollutants can then seep into the groundwater below. And the issue is that a lot of times you don't know that these tanks are leaking until they've leaked enough pollutants that they leak a significant amount of pollutants. Um, it'd be like if imagine you had like a leak in your gas tank or something. You wouldn't really know you had a leak until it's too late. It's hard to all of a sudden discover a leak in your gas tank. You know, until you ran out of gas or something. Um, so modern storage tanks, they're going to be contained in concrete as a result of this, because even if the tanks leak some, they're at least in concrete where it can't get through the concrete. And there's other different safety features as well. And this is just kind of a diagram summarizing everything we've talked about. So you got runoff from the rain that can, all the fertilizers and stuff from the field can flow into your bodies of water. They can also percolate through this grayish area right here. That's that porous and permeable layer of the aquifer, that the recharge zone where the water can get back into the aquifer and recharge it. However, if you have pollutants in the area, they can also get into the aquifer and contaminate the groundwater. All right, so cleaning up groundwater pollution, it's very, very difficult to do it, and it's it's one of the bigger environmental problems in the world, and the reason is because the water's underground. It's really hard to get access to it, and there's a lot of it. And even if say you could completely pump out all of the groundwater on the earth and just decontaminate all of it, remove all the pollutants, and then you pump it back into the ground, you still face the problem of those pollutants clinging to the rock and the soil from where they came from. And so you could clean out all the groundwater, then pump it back in, and then still add some of those pollutants back into it. It would be like, imagine like I don't know if you ever like had a water bottle that you filled up with like Gatorade or something, and then you drink that Gatorade, and then you refill the water bottle back up with water. You can still taste some of that leftover Gatorade, and that's like the similar principle here. Like you kind of have some of those, some of that Gatorade that clings into the water bottle. Ocean pollution. So whenever we think of ocean pollution, we typically think of like oil spills. When in reality, and those are an issue, and they do cause a lot of pollution, but in reality, a lot of the, up to 85% of, or even higher than that, of ocean pollution is actually coming from activities that are on land that's closer to the coast. So that can be like runoff from things like oil, toxic waste, medical waste that find their way into the coast that line the oceans, and then they will, then that water will go further out into the ocean. There's also some just not very good laws for ships and how they need to get rid of their wastewater and their garbage. In certain areas of the ocean, ships can just literally just dump the wastewater and the garbage overboard. Or they might just do it anyways because there's no one around to catch them. Like it's like, oh, what do we do with this garbage? Well, oops, I'm gonna throw the bag over the ship. Like do something about it. So it's really a pretty tricky issue, and especially whenever it's occurring in the sensitive coastal ecosystems like your coral reefs, where any sort of change in that aquatic ecosystem can really affect the life that lives there. Um, okay, so as we talked about, a lot of the oil that again, when we think about oil contaminating the ocean, most of that oil doesn't come from these oil spills from oil tankers. They actually come from oil being washed into the ocean from the cities and towns that are right along the coast of the ocean. So even areas like Houston would be a big city where we technically we contaminate the ocean because there's a lot of oil that can run off from the mainland and get into the ocean. So if you can limiting any of these non-point sources is going to be how you clean up the oceans. So in other words, rather than trying to clean up the oceans directly, the idea is let's try to limit the amount of pollution in the cities that line the coast, kind of stopping it at its source. This is a map of all of the major oil spills in North America. The biggest one and most recent one was the one in Gulf of Mexico, the Deepwater Horizon BP oil spill, where you had just millions of barrels of oil right along in the Gulf of Mexico. So another thing to consider when we talk about water pollution is that imagine you put contaminants into the water. Those contaminants will break down over time, but some pollutants will actually build up in the environment. They essentially will sink to the bottom of the body of water and they just stay there. Think of like if you have like your sink and maybe you have like some hair like that gets into, like my wife's got all kinds of hair, that will get into the drain and it'll just build up over time unless I clean it out. And it's the same thing with certain pollutants where some of them will, go down the drain and they'll wash away, but others will build up in the drain and will eventually get to such a level where they can cause a problem. And then there's the idea of biomagnification. So biomagnification, I'll just jump to the next slide and explain the idea. It's where you have, say you have a thing like a zooplankton, some sort of microscopic organism, and you have a chemical like DDT. In the zooplankton, there's really not a whole lot of the chemical, and it's not a big deal, but say you have a small fish that eats that zooplankton, all of a sudden that pollutant increases by a factor. It goes from 0.04 to 0.5, and then you have a large fish that eats that small fish, or eats multiple small fish, eats 4 small fish or something, that 0.5 goes to 2. And then you have a bird like the osprey that eats, you know, 12 or 13 of these large fish, and then as humans, we then eat this bird, and you kind of start seeing how this DDT chemical goes from a concentration that's not a big deal to something that can actually be a pretty big deal. And it's for that reason that a lot of government, a lot of states will regulate how much seafood they bring in from different areas of the world. Because depending on which area of the world you're in, that body of water might have different levels of certain things. So a big one is like mercury in your tuna, where you want to be careful how much tuna you're eating or which areas of the world you're getting your tuna from, so that you're not getting too much mercury. So cleaning up water pollution, there's a lot of different ways to do it, but at the end of the day, you kind of have to have laws in place that make it illegal to do it, and laws in place that deter people, like things like companies uh, from disposing of their chemicals illegally. So making sure there's large enough fines. I mentioned like the oceans, where there's kind of some goofy things going on with ships in the ocean, where it's like they could just get rid of their trash overboard, or there's not really there may not be enough consequences for breaking those rules. The Clean Water Act was kind of was the very first act that actually tried to address the idea of water pollution. And the goal was by 1983, so in 11 years, they wanted to make every single surface water clean enough to fish and swim in, which is a very bold goal, and they didn't meet that goal by any means, but at least it made the idea of protecting our bodies of water and cleaning up our bodies of water a thing. And today we have about 30, the percentage of lakes that are fit for swimming has increased by about 30%. So I guess that's pretty good. I mean, depending on what your standards are. Um, and if I go to the next slide, I mean, this is just a summary of all the different laws. I'm not going to read each one of them to you, but I would read them on your own, just so you have an idea of the different kinds of legislation that's being passed. Things that are protecting, that are limiting, pollution of groundwater, and then pollution of oceans. You kind of went from the very general up here, where it's like, okay, we just need to stop pollution, to more specific, like, okay, we need to protect our oceans in 2000. And that's kind of how laws go. Like, as people break the laws, you start making laws more and more specific as you go on in time. Okay, so I'll do it for this section.